Okay, quadratic equations. What we will be touching with quadratic equations is as follows. We will determine the axis of symmetry. We'll determine minimum or maximum turning points. Okay. By this, we'll determine also if the parabola of the curve is bent up or down. So to make it very simple is as follows. Well, what's a quadratic equation? Well, first of all, have we seen quadratic equations? Yes. Have we been working with quadratic equations? Yes. The answer to those questions is yes. The thing with quadratic equation is that we have seen them as what we call polynomials. So if we get an equation as follows, say for example, you have an equation that says x squared plus 2x minus 8. That is a quadratic equation. Okay, we call it a polynomial, but it's still a quadratic equation. And let's say the same kind of equation, let's say it looks like negative x squared negative 2x plus 8. Is that a quadratic equation? Yes, it is. So I want you to pay keen attention to this part here. Notice the value in front of this x squared and notice the value in front of this x squared. I'm going to write it in red. The value in front of this x squared is negative 1. And the value in front of this x squared is 1, positive 1. Okay? Now, when we have a quadratic equations, we can write them in the general form of a quadratic equation, which is ax squared plus bx plus c. That is a quadratic equation also, all right, in general form. Now notice the a is the value in front of the x squared, the value in front of the x squared. The b is the value in front of the x, in front of the x. So let's start with this one here. Okay, now whenever you have something like this, it's good to identify a, b, and c. In this case, we have a equals negative 1, b equals negative 2, and c equals positive 8. All right, now this curve here will be something that will look like this on a graph paper. This one here will look like this. There are key features that you can use to identify if it bends this way or bends this way. So here are the key features. Now remember, these are the values which we have here. And the values for this one here, the a will be positive 1, the b will be positive 2, and the c will be negative 8. All right. Now, this point here where this curve turns is known as the maximum because it's way to the top. This point here where it turns is known as the minimum turning points. All right. So the way you're going to work this out is as follows. The axis of symmetry is given by the equation negative b over 2a. Right? And if we are working with this, notice what happens. If we use this equation, we put equals negative. What's the value of b? Negative 2. So we put negative 2. Note that this minus and this negative are two different things. Over 2 times a, which is negative 1. This now gives us negative, and this negative and negative will make it a positive, so that becomes 2 over 2, which then gives us a negative 1. All right. Now this result here, if you notice, this is for the axis of symmetry. All right. Now because you get a negative 1 now, we will see that this is a maximum turning point. If you get a positive value, then that will then be a minimum turning point. So let's work with this piece here for right now with this particular equations. So we get a negative 1. Now when we take this negative 1 and input it into this equation, we would get negative x squared negative 2x plus 8 equals y, which will give us our y value on the equation. Negative negative 1 squared negative 2 negative 1 plus 8, and there we get negative 1 positive 2 plus 8, which gives us a positive 9, which is equals to y. So what is saying that the point where this curve turns, it is at the point when x equals negative 1 and y equals positive 9. Okay, so what can we say? that whenever the value in front of the x squared here, whenever this value a, so let's write it here. Whenever a is less than 0, being that a is then negative, okay, then the parabola is convex. I'm going to use the word convex for the science people and also for the normal people, in the sense that convex is what curves, is just the curve, okay, and therefore has a maximum turning point. Okay, so let's go over this piece here again. Remember, we're touching this equation here. If the value in front of the x squared is 0 and less, then that means that the curve will curve this way, and therefore will have a maximum turning point. Where is that point? Well, we solve by substituting the values a and b into this general equation, which gives us the x equals -1, which is the x value, and then we substitute in here to get the value for y, which is the point of turning. So we can conclude that whenever a is less than 0, being that it is then negative, then the parabola is convex, meaning curve up, therefore has a maximum turning point. All right, so let's go with another example. Okay, so let's try this example. We have been given this example. Remember, try look at this equation as saying ax squared plus bx plus c. So a is equals to -2, b is equals to +5, and c is equals to 3. So we put that into our equation of our axis of symmetry. And as you can notice that since a is -2, will this parabola be a maximum or minimum? If you said maximum, you're correct, because like how we said here, if a is less than 0, then it's a maximum turning point. And which point is that? Well, recall the equation -b over 2a, -b, which is 5, and 2 times a there. So therefore we end up with -5 over -4, which then gives us a 5 over 4. Notice we get a 5/4. This is the value of the x. All right, and so we take this value now and input it into this equation to get the y value. We will not need to go to such an extent. All right, just note the axis of symmetry is to calculate it this way and determine if it's maximum or minimum turning point. All right, that's all. However, for the ones who want to find what's the y value or the turning point, then this is what you will need to do. Since you already know the x value, which is at the axis of symmetry, you're going to input into that equation. You put -2, and you put 5 over 4 squared plus 5 times 5 over 4 plus 3. That gives us -2, 25 over 16 plus 25 over 4 plus 3. The 2 and the 16 cancel out, giving me 8. So therefore now this looks as to say -25 over 4 plus 25 over 4. I mean this, and this is 8, sorry about that, plus 3 over 1. Remember, a whole number over 1 is still the same number. So the LCM is 8. We have here -25. 8 divided by 4, that's 2, times 25, that's 50. 8 and 24. This gives us -25 plus 50 plus 24. That's going to give us 49 over 8, right, which is 6 and 1/8. So the turning point will be at the value of 5 over 4 and 6 and 1/8. You may state it as a decimal or as a mixed number, but the primary thing is to determine if it's a maximum or minimum turning point. It's a maximum turning point if the value in front of the x squared is negative. Okay, that's the key point. Now let's try one when it's a minimum turning point. We will see what then happens. Whenever, so let me write it here, in a quadratic equation, for example, ax squared plus bx plus c, if a is greater than 0, then it has a minimum turning point. Okay, now how does that work? It's the same process again. Axis of symmetry is the same equation. That doesn't change. You put negative b over 2a. Well, let's take an example with numbers so we can work with this. All right, so our example will be as follows. Consider that we have our equation y equals x squared plus 2x minus 8. Here a equals 1, b equals 2, and c equals negative 8. Therefore, when we input into this equation, we end up with negative b, which is 2 times 1, giving us negative 2 over 2, which is negative 1. Notice now that the axis of symmetry is at negative 1. All right, so we input this value into our equation, which is this one here, so we end up with y equals negative 1 squared plus 2 times negative 1 minus 8, which is 1 minus 2 minus 8, which is then negative 9. Therefore, the x value is negative 1, negative 9. That is the point of symmetry for this parabola. So this means that the curve is opening upwards. It has a minimum turning point. Why? Because the a value is positive. All right.